Are we ready to get started again? Today we're going to look at integration by substitution, but today we're going to focus on natural logs. And when we work with a natural log in substitution, we normally, and at the beginning here it's always going to be, that u is going to be that natural log of x or some form of the natural log of x. Maybe like a natural log of 3x or the natural log of 7x. Something pretty similar to that. So let's go ahead and look at a couple of examples. They're not going to be too miserable. I think it's going to be one of the easier lessons that we do here. So if I have the natural log of x, quantity to the seventh over x dx. We don't know the integration of the natural log of x. But if we let u equal the natural log of x, as I said in the beginning, letting your u equal that natural log of x, the derivative then, derivative of natural log of x, remember we take the derivative of the variable or the function there, the derivative of x is 1, divided by what we take the natural log of, and then dx. So if I come over to my integration, well, my integrand, I have a 1 times the natural log of x to the 7th. So there's my 1 over x, and here's my dx that I've got. So my du is going to fit very nicely into this integrand. So now I can go and integrate u to the 7th du. Integration of u to the 7th is u to the 8th over 8 plus c. I can replace my u with the natural log of x. So my original function f of x is the natural log of x, quantity to the 8th divided by 8 plus c. In example 2, we're going to see that natural log is going to be in the denominator into a quantity. Again, though, if we let u equal the natural log of x, du this time, again, is 1 over x dx. And if we look over here, we have a 2 over x dx. But remember, we can multiply anything by 1 and get the same value. So I still have this 1 over x dx to do my du substitution. So that 2 is just going to hang out there. So I can write this as 2 over u to the 3rd du. Remembering again that natural log of x is u to the 3rd. As we look at that u to the 3rd in the denominator, remember we cannot integrate it into the denominator. We got to bring it to the top. To bring it to the top, we're going to write it as a negative exponent. So we have the integration of 2u to the negative 3rd. Now we can go and integrate. We can increase that exponent by 1. So we get 2u to the negative 2nd, dividing by that new exponent of negative 2 plus c. A lot of us in our homeworks in previous sections went ahead and integrated this and integrated it again until we got to a natural log. We're only going to integrate this once at this point in time. So don't try to get this down to a 1 over u. We're going to leave it just as 2u to the negative 2nd over negative 2 and then clean this up. How are we going to clean it up? We can divide those 2 out. And then we have u to the negative 2nd we can bring to the bottom. So we get a negative from the bottom there, 1 over u squared plus c. We can replace our u with the natural log of x. So the negative of 1 over the natural log of x quantity squared plus c. And that's our final answer. In example 3, here we see that we don't have just a natural log of x. We have a natural log of 2x. Does that matter? Well, if we let our u equal the natural log of 2x, variation of that natural log of x, what is the derivative of the natural log of 2x? Well, we take the natural log of 2x. The derivative of 2x is 2, divided by that new, or that original function of 2x. So 2 divided by 2x is going to reduce again to 1 over x. So we should see that we still end up with a 1 over x. Again, over here, we can split this 3 into 1 times 3. So here's our 1 over x dx. So we're looking at the integration of 3 over u du. Well, in this case, we have 3 over u. We can split that up into 3 integrations of 1 over u du. Since 3 is a constant, it can come out to the outside of the integration symbol. The integration of 1 over u, well, that just happens to be the natural log of the absolute value of u plus c. We replace our u with the natural log of 2x. So I had 3 times the natural log of the absolute value of the natural log of 2x plus c. And that's going to be our final answer, our original function f of x. Finally, example 4, we're going to set natural log just to in a radical. So we're going to let, again, u equal the natural log of x. du is going to be 1 over x dx. Again, we have a 1 times that integration, so there's our 1 over x dx. So my integration becomes u to the 1/5 du. Remembering we have the radical, or the 5th root of natural log of x. Our exponent is 1. Our index was 5, so we have the fraction of 1/5. We can go ahead and integrate u to the 1/5. U to the 6/5 over 6/5 plus c. Take that 6/5, multiply by the reciprocal, we end up with a 5/6 u. I can go ahead and replace that u with the natural log of x to the 6/5 plus c. And that's going to give us our original function f of x and end our examples on natural logs of x integration. So enjoy integrating.